Hello class and welcome to Unit 2 Video 4. Today we're going to go ahead and take a look at special functions. The learning target for today is that you can depict from a graph the type of function, including absolute value, piecewise, and step functions. So before we go ahead and get started, I just want to maybe look at the names of these and give you a visual of what each function should look like. Okay, so the absolute value, whenever you graph an absolute value, it's going to have a, V shape is what it should be. Let's see if I can try that again. Should be a V shape. One way you can maybe remember that is the value, so it should be a V. The other function we're going to take a look at today is the piecewise function. And I remember it because it's broken into pieces. So an example of what it might look like is you might have an open circle and going this direction, and then I might have a closed circle and going this way. Okay? There's two pieces here. There's this function and there's that function. So there's pieces of a function put together. And then the other function we're going to look at is a step function. Well, it actually looks like you would think it does. It has steps. Usually one's got an open and a closed circle. Open, closed circle. And if you could see, you could step up these. So that's an example of a step function. So those are three of the different functions we're going to go ahead and look at. We're going to start with looking at the step function today. So here's an example of a step function. The cost of postage to mail a letter is a function of the weight of the letter. So if you go to the post office and you mail a letter, okay, it might be filled with one piece of paper or it might be filled with 6 pieces of paper, but as long as it's under 1 ounce, they're only going to charge you 39 cents, which this is different today, right? I think the price of stamps has went up. So it's a flat rate for anything less than 1 ounce, okay? The second you go over 1 ounce, though, they're not going to charge you just 39 cents anymore. They're going to charge you 63 cents, all the way up until 2 ounces. So it's a nice flat rate for each one. They don't want to have to sit there and individually print out stamps every time somebody comes in and weighs it, right? So that's why they do a flat rate. You can send, your letter in the mail for the same price every time, as long as it's not over an ounce. So is this linear? It is not linear, and the reason is because there are no in-between prices. If something weighs 0.2 ounces or 0.9 ounces, you're still going to pay the 39 cents. Doesn't matter how much it weighs. Okay? If the 0.2 price was different than the 0.9, and for each different level of ounce there was a different price, then it would be linear. Okay. So what is the cost to mail a 1.5 ounce letter? Well, here's my weight, not over in ounces. So I can go up to 1 ounce and pay 39 cents, but this is over 1 ounce, so I can go up to 2, which would be my 1.5, right, would be less than 2, so I would have to pay 63 cents for my 1.5 ounce letter. So this is an example of what we call a step function. Usually deals with flat rates that you have to pay for each one. So let's take a look at a step function. The notation, which you might see here, is you got these brackets on here. That would represent the step function. So the symbol, which we have here, means the greatest integer less than or equal to x. So the step function is also called the greatest integer function. Okay. So let's just first dive in and look at the graph. Okay. If you notice here, we always have a closed and an open circle, and then the pattern with the closed and the open circle continues to repeat. There is a reason for this. It says it's a function. Okay. In order to be a function, you must pass the vertical line test, which we covered in the first part of Unit 2. Okay, so if I were to run a vertical line here, you guys might be like, oh, you're touching 2 points, but you are not. One is closed, so it is included, and the other one is open, so it is not included. So if you have one closed and one open, you are still passing the vertical line test, okay, because you're only going through 1 point. If I were to go ahead and close this, then I would fail the vertical line test. So it's very important when you graph an absolute value to make sure that you have one closed, one open, and that it would pass the vertical line test. And the same will go true for piecewise functions. A lot of people make mistakes on that. So it's easiest to come up with our step function from our chart. So let's explain what we have going on our chart here. Okay, they're saying that from -3 to -2, I'm getting charged a flat rate of -3, whatever. I don't know what realistic money problem we could do with this, but if we're talking about money, that would be my flat rate. So here's how I would think about graphing it. Do you guys see how the -3 has the equal to? It's going to be the ordered pair -3, and then my y value is -3, -3. And since it's equal to, on my graph, I need to go ahead and it should have a closed circle. So let's take a look. We have 1, 2, 3, -3, down 3. Do you guys see how it's closed? So that matches up with what I have here. Then the other side is -2, and my y value again is -3. And since it's not equal to, when I go to that point, it should be open circle. Okay, so -2 down 3, and if I take a look, open circle. And then everything in between that has a value of -3. I could then repeat it, and let's just maybe check another one. We would have, this is 3, and it matches up with my y value of 3. And since it's equal to at 3, 3, I should have a closed circle. So 1, 2, 3, there it is, closed circle. Then if I look at 4, it's 4, 3. Once again, that's not equal to, okay, so that would be an open circle. So I'm going to go 1, 2, 3, 4, up, 3, open circle. Okay, so that's how we can graph our step function. Here is another real life example of where a step function would be used. Okay, so the No Leaks RS Plumbing Company charges $60 an hour or any fraction thereof for labor. Okay, so basically what they're saying is if they come out to your house and they spend 10 minutes there, they're charging you $60. Okay. Complete the table and graph the function where x is the number of hours of labor and c of x is the total labor cost. Okay, so they come out, they spend 5, 10 minutes there, they're going to still charge you $60. So the cost is $60. Okay, now we went over an hour, talking about from hour 1 to 2. Well, since hour 1 is $60, okay, we're not going to include it here, so it's just going to be not equal to, and then we have x, and now we're going all the way up to 2, so exactly 2 hours. So now they're there for 1.5 hours. How much is it going to cost for them to be there for 1.5 hours? Well, it's $60 per hour. So now it's going to be 60 plus another 60 is 120. Okay, so they're charging us 120. Now, they've been there for more than 2 hours. So we're going from 2 to 3 hours. So this is going to be plus another 60. It's $180. And then I'm going to keep filling this out. Hopefully you're seeing the pattern here. 3 to 4 hours. That's going to be $240. Add another 60 every time. And then from 4 all the way up to 5 hours, that's going to cost $300. So here is my step function. Now what we need to do is we need to go ahead and graph it. So I'm going to make myself an axis here. There it is. And let's label. X is going down here, and what is X representing? X is our number of hours, so number of hours. And I'm going to label, we're going up from 0 up to 5, so 1, 2, 3, 4, 5. And on this axis is going to be the cost. Okay, so there's our cost, and since it goes up by 60s, I'm going to label it by 60s. So we got 60, 120, 180, 240, and 300. And now I'm going to graph my step function. Okay, at 0, it's $60. Okay, but if nobody comes out to your house, it's essentially what 0 hours means. They're not going to charge you, right? So it's going to be open circle. Plus, it's not equal to. So 0, 60, open circle. And then I would have 160. Has that equal to? So now it's closed circle. If they come out to your house for a half an hour, how much do they charge you? $60. If they come out for 45 minutes, it's still going to cost you $60. So that's why there's this little line in between. Anywhere in between 0 and 1 hour, they're charging you $60. Now I'm moving on. Hour 1. Okay, still getting charged 60, but I have to make my steps. So it's going to be open circle at 1, 120. So open circle. And then at 2, 120, closed circle. If they're there for an hour and a half, once again, they're still charging you 120 and everywhere in between here. So there's my next step. Now I have 2, 180. open circle. At 3 we have closed, and there's my step. 244, creating my next step, and then my last one. Okay, so it's not, mine's not perfectly to scale, but as you can see, there's steps, and once again, would it pass the vertical line test? If I go ahead and just, my vertical line's not very good today. If we went up and down, I would only go through one point. I would only go through this point. This one's not included. So I would pass that vertical line test. Okay. So there is example 1. That is our step function, which looks like stairs. Now we're going to move into our absolute value in piecewise, but before we do that, I just want to let you know a few names of some linear equations. Okay, so one function that is linear is the constant function. Okay, it's called f of x equals, in this case is an example of f of x equals 3, or same thing as f of x is y equals 3. And some people maybe forget why this one is y equals 3. Okay, if I look at this point, it's negative 1, 3. If I pick this point, it's 1, 2, 3, 3, 3. If I pick this point, it's 4, 3. If I look, there's a 3 for every single y value. No matter what point I pick on this line, my y value is always staying 3. That's why it's y equals 3, okay, or f of x equals 3. If I have a horizontal function, one thing to take note of is there's no slope. If I have no slope, it really means m is equal to 0, right? We're not rising, we're not running. Okay. Like I said, it's horizontal. And whenever you have a horizontal line, it's always y equals whatever the number is, whatever the y value is for that. So there's our constant function. Okay. The next one is your identity function. Okay. This one is y equals x, or f of x equals x. What is my slope with this one? Well, what's in front of my x? 1. So my slope is equal to 1. And my y-intercept is really my b value. And what does that look like? Well, it's 0. There's nothing written there. My y-intercept is 0 because we're going through 0, 0. And once again, the equation is y equals x. And here's y. If I plug in 1 for x, I get out 1 for y. If I plug in 3, I get out 3. So my ordered pairs are 3, 3, 4, 4, 5, 5, negative 1, negative 1. You know, whatever I plug in for x, it's equal to y. The biggest thing to remember is your y-intercept is equal to 0. Some people get confused on if I tell you to graph this. They're like, I don't know how to graph that. Well, you do. Your slope is 1, and your y-intercept is 0. So start out and then go up 1 over 1, up 1 over 1. And if I remember correctly, I think there's a problem like this one on your homework. Okay. So constant is a horizontal line, no slope, and then our identity function. It's called identity because whatever you plug in, you get out. Okay, you just get back what you started with. So those are both what we call linear functions. Linear, because remember, they are made up of lines. Okay, this is a line and this is a line. And now we're going to move into our absolute value function. That's the one where I told you it looks like a V. Okay. So absolute value, remember we've covered this. It is distance, and it is always a positive value. So I'm plugging values into my absolute value function. Some people make mistakes here because they forget to make it positive. So absolute value of negative 3 is 3. So here I would have 3. Plug in absolute value of negative 2, get out 2. 1, absolute value of 0 is 0. Plug in 1, absolute value of 1 is 1, 2, 3. So if I plot these points, negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, you can see that I will have a nice V shape. Okay. So this is what my absolute value function looks like. One thing I want to talk about is what we call the domain and range. Okay, domain. Okay, domain. We've talked about it in terms of ordered pairs in the first half of Unit 2, but now we're talking about it in terms of a function. Okay, I see there's ordered pairs here, but do you see how there's all these other values in between here because the lines are connected? They're really representing multiple, infinitely many little points. Okay, so the domain is our x values, And so this is my this is my x-axis. So if I look, this arrow symbolizes that my arrow is going to keep going all the way to the left, and it's going to keep going all the way to the right. It seems silly to say, but it really means to keep going on forever and ever and ever. Okay, that's what that arrow is symbolizing. So my domain, if I'm going to keep going all the way to the left and all the way to the right, essentially every single point and every single x value on my x-axis is in my domain. So that is every single number you could possibly ever think of, I would include in my domain. So if it's going to keep covering everything to the left and everything to the right, you want to call that, it's what we call the numbers, they're called all real numbers. And we talk about real numbers a lot in math, so there's actually a little symbol. Looks something like this. It's a fancy little R. So 2 lines, and then you kind of make an R. So this fancy R is to represent all real numbers. So if you want, you can write it like this, or you can write out all real numbers when asked for the domain. Now, the range. Okay, the range is your y values. Well, my y-axis is up and down, so I always recommend looking down and then up. So my arrows are going to both keep going up. So will I ever touch any or go down towards these y values? No, I will not. So my lowest y value is right here. And what is that y value? It's when y equals 0. And then we're going upwards. So my range is y is greater than or equal to 0. Okay. So the range is probably the hardest part for an absolute value function. The domain for absolute values is always all reals. So just something to keep in mind when we're talking about the domain and range. Okay. Now that we talked about an absolute value function, you can always take an absolute value function and write it as what we call piecewise. Do you guys see 2 different lines here? There's this function and there's this function. So what we're going to do is we are going to graph it as a piecewise function. Okay, it's a function that can be written using 2 or more inequalities. For our purposes, we're going to just keep it to 2 inequalities, and we're going to graph it from there. So you could think about it as negative x, okay, y equals negative x, for x less than 0. If I look over here, less than 0. This direction, and would you say my slope is negative 1? Yes, and my y-intercept is plus 0. Okay, and would you say this one is my identity function for x greater than or equal to 0? Yes. So they're just trying to illustrate that you can rewrite the absolute value function as a piecewise, but let's use this information to figure out these points. So negative 3. In order to figure out where I plug negative 3 into my piecewise, I would say this is for x less than 0, and this is for x greater than or equal to 0. Negative 3 is less than 0, so I plug it in here. So I would have negative negative 3, which gives me 3. Negative 2 is less than 0, so I'd have negative negative 2, so I would have 2. Negative 1 is negative 1 less than 0. Yes, it is. So I plug it in here. Negative, negative 1, 1. And now 0. Is 0 less than 0? It is not. But if I check my other function, it says x is greater than or equal to 0. So now I plug it into here. So 0, plugged in for 0, I have out 0. This is the identity, right? Whatever I plug in, I get out. Then I have 1. Is 1 greater than or equal to 0? Yep, so I plug it into my function. Plug in 1 for x, which just gives me 1. Can plug in 2 and 3. And then if I go ahead and graph it, I would have negative 3, 3, negative 2, 2, negative 1, 1, 0. And you should see that you are given a V-shaped absolute value function. So now we're going to go ahead and graph some functions. I would like for you to start trying to identify the difference between some functions. If I tell you to graph this, okay, this is a line. So my slope is 1 and my y-intercept is 0. You guys are all comfortable with graphing that. If I tell you to graph this is an absolute value function. So then we're going to have to use our tips for graphing absolute value. if I give you something that looks like this, not equal to. This is our piecewise, so we'll have to use our techniques for graphing piecewise. So we have to be careful. This is a linear. You guys know how to graph linear. I do believe there's a few linear on your homework. Absolute value has to have those absolute value signs, and then our piecewise. Okay. So in order to graph this first one, first of all, I should say, well, what is it? You need to look at it, and I see absolute value. So this is an absolute value function. Okay, and here is how you graph absolute value. You need to think about what's inside the absolute value with the x. That's what moves it left and right, okay? And it's always the opposite of what you think, okay? So x values, you guys agree x is on our x-axis? So that moves things to the left or to the right. And when it's on the inside, it's always opposite of what you would think. So this is actually going, it looks like right one, but it's going left one. It's opposite. And then you look at the number on the outside, and that moves it up or down. And that's exactly what you would think about, okay? So if it's plus 2, so this is moving left 1, and this is on the outside, so it's moving us up 2, okay? These two numbers are giving us what we call the vertex of our absolute value function. The vertex is the point, this would be our vertex, is the point of our v. Okay, that's our vertex. So if we're going left 1, that would be -1. So my vertex is -1, and up to 2. So I make a table of values, and your vertex is the middle thing to go in your table. So when you plugged in -1, you got out 2. Then whatever you have for your vertex, just pick a few numbers less than it and above it. So what numbers are less than -1? -2 and -3. What numbers are bigger than -1? Well, 0 and 1. Okay, so 5 numbers are usually good for that. Then I go ahead and I plug them into my function. So I plug -3 in. So f of -3 equals the absolute value of -3 plus 1 plus 2. When people graph these, a lot of times they forget the absolute values. Just be careful. So -3 plus 1 is -2. Plus 2, the absolute value of 2 is 2 plus 2, so you would get 4. Now I'm going to go ahead and plug in -2. So f of -2. You don't have to write all of these out. You're probably going to get pretty quick at figuring them out. But absolute value of -2 plus 1 plus 2. -2 plus 1 is -1. The absolute value of -1 is 1. 1 plus 2 is 3. If I plug in 0, 0 plus 1 is 1. Absolute value of 1 is 1. 1 plus 2 is 3. And if I plug in 1, 1 plus 1 is 2. Absolute value of 2 is 2. 2 plus 2 is 4. Now I'm going to go ahead and plot these points. And I should be thinking, what does an absolute value function look like? It should be a v, So we have -3, 4, -2, 3, -1, 2, 0, 3, and 1, 4. And I should be seeing that this is my absolute value function. So there it is graphed. The other thing we will be asking you is to find your domain. Okay, so domain. That's your x values, so we're looking to the left and to the right. This is going to keep going all the way to the left and all the way to the right, so it's going to cover every possible number on the x-axis you can think about. So you can either write all real numbers or all reals, or you can write the fancy r, okay? There's that. And then range. That's your y value. So look down. There's nothing here. The first y value you see is right here, which is at 2. And then we're going bigger than 2. So y is greater than or equal to 2. Okay. So there's my domain, and there's my range for my absolute value function. Before we move on, I want to just make sure we're all okay with making up or continuing on an absolute value functions when you have to graph them. So what if you have this one? Absolute value of 5x minus 7. Okay. Do you see how there's nothing being added or subtracted here? So I'm just going to go ahead and write plus 0. So that means my vertex is 0, comma, and the end is negative 7. So your vertex would be 0, negative 7. So that's where you put on the middle of your table. Then pick numbers 2 less and 2 above. What if you have this? Okay, to find our vertex for this one, remember it's always the opposite of what you think on the inside, so it's minus 5, so it really means we're going to the right 5, so it's positive 5, and then this stays the same, negative 1. So once again, you put that in the middle of your table, and you pick numbers below and above. Okay, so that's our absolute value function. If you have questions, let me know, but please, please, please make sure that when you are graphing it, it looks like a V. Okay, if you don't have a V, it means you made a mistake somewhere. Now we're moving on to our piecewise function. Okay, so we are going to graph f of x equals, and now here's my first piece and here's my second piece. So we're graphing two functions. So if I'm going to graph two functions, I'm going to go ahead and make myself two tables. Sorry, can't make straight lines on here today. My first table is going to be graphing the function x minus 4. So y equals x minus 4. And I follow whatever this says. It says for x less than or equal to 2. So whatever this number is listed here, I start out both my tables with that number. And then I'm just going to make a note to myself. This one is not equal to, so this is an open circle. This one is equal to, so closed. Don't want to forget to close it on my graph. Then I just read it. It says x is less than or equal to 2. So what numbers are less than 2? 1, 0, negative 1. And whatever function is listed here, y equals x minus 4, I plug my numbers in to get out my y value. So 2 minus 4 is negative 2. 1 minus 4 is negative 3. 0 minus 4 is negative 4. And negative 1 minus 4 is negative 5. So there is my top part or top piece of my piecewise. Okay. Now I'm going to move on to my next function. It says for x greater than or equal to 2. So what numbers are bigger than 2? 3, 4, 5. And my equation is y equals 1. We talked about what does y equals 1 earlier. It's a horizontal line, and all my y values are 1. If you notice, there's no x with it, so that means I can't plug it in anywhere. There's nothing to plug it into. So if I plug in, I'm putting in quotation marks, plug in 2, there's nowhere to plug it into. All I get out is 1. If I plug in 3, I get out 1, 1, 1. Okay. So let's go ahead and graph this. I'm going to put this one in this purple color. So open circle at 2, negative 2. So 2, negative 2, open circle. 1, negative 3. 0, negative 4. The rest of them are closed. 1, negative 5. Notice all my points are going here. So I draw the arrow going in that direction. It's only going in one direction when you do a piecewise, and it's for x less than 2. So to the left. Now I go ahead and I'm going to graph this one, and I'm going to do it in green. 2, 1, closed. So 2, 1. Then I have 3, 1, and 4, 1, and 5, 1. They're all going this way. So this is closed. And there would be my piecewise function. Okay, and I would just ask myself, would this pass the vertical line test? Okay, this is closed and this is open, so it's passing here, and I'm only touching one point at a time. Here's where people lose points on their quiz. They go and they draw a line all the way through and keep going. Would this now pass the vertical line test? No, it would not. It'd be touching 2 points at a time. So make sure you're careful with your piecewise. Okay. All right, so there's example 3. One last example. We want to graph this piecewise. Okay, so we're going to make our two tables. And every single time we start out our tables for piecewise with whatever the number is at the end. So I'm writing 0 and 0. So the top one, I'm going to draw an arrow here, and I'm going to do the bottom function over here. This says x is less than or equal to 0. So it seems silly, but I'm going to put an open circle around my 0 to remember open. So x is less than 0. What numbers are less than 0? -1, -2, -3. It's probably enough. And then this one is for x greater than or equal to 0. So 1, 2, 3. Now we go ahead and plug them in. This is for x plus 2. So y equals x plus 2. I plug in 0. 0 plus 2 is 2. -1 plus 2 is 1. -2 plus 2 is 0. -3 plus 2 is -1. Okay. I'm going to go ahead and graph this one. So I have 0, 2, open circle. Then I have -1, 1, -2, 0, -3, -1. So notice my dots are going to the left. So I'm going to draw my line to the left. If I look over here, this is y equals x this time. That's our identity function, okay, which we talked about earlier. So everything you plug in for x, you get out for y. So if I plug in 0, I get out 0. If I plug in 1, I get out 1. 2, 2, 3, 3. So I plot my points, and since it's equal to here, it's closed. So 0, 0 closed. 1, 1, 2, 2, 3, 3. If you kept guessing, it'd be 4, 4, 5, 5. And these are all going to the right. And then once again, I would check, would this pass my vertical line test? Up and down, am I only touching one point? Yes. So here is my piecewise function graphed. That is the end of video 4. If you have any questions on the notes, please let me know. Otherwise, have a good day, and I'll talk to you later.